Hi, welcome to the presentation. I'm Daniel.
And I'm David.
So let's just get straight into it. This is our prototype. This uses suction cup mounts, so this will mount to like a window or really any door and just anything that has glass on it. And then we'll charge off of the solar panel that's right here. And then using these buttons, you can turn on multiple lights. The solar panel will charge a battery inside the unit that's built in. It's right around here. And then has a battery status indicator, has a USB charge port on the side, and can be used in a lot of different ways.
So our original problem statement to get to where we are was essentially to help developing countries that have very little access to safe and affordable light. And according to Core 77, in 2017, roughly a quarter of the world's population didn't have access to electricity at all. So that made millions of people rely on dangerous and dirty sources of light like kerosene, which is detrimental to their health. After revising our problem statement, we realized that aiming to help the developing world as a whole is pretty grand and would be too wide of a scope for us to really achieve. So we narrowed it a little bit. Essentially, it obviously can still be used in developing countries, but more targeted towards off-grid living. So it could be used in a van or an RV, or still in your own home or a car even. So anywhere that you can stick to a window, it can charge with solar power and provide simple, easy, clean lighting that you can use safely at any time.
So linking to our problem statement, we have our objectives. The big ones were to have an affordable light, so it has to be cheap. It has to use the sun's power to charge a battery where you can't just plug it in, and that's how it works. There's an infinite of those. It has to withstand abuse, such as being in a car. It has to be very versatile and be used in different scenarios, such as like in a car or at home, or even while camping.
So our main objectives, as Daniel already mentioned a little bit, it has to be affordable, and we achieve that by having a total component cost of about $18. The use of the sun's power to charge, which is easily achieved by the solar panel inside here, which it charges the batteries quite quickly. It can withstand abuse. It has a movable mount that allows it to flex a little bit while it's on a car windshield, and that keeps it from falling off. It can be used in plenty of different scenarios. You could put it in an RV or even like a sunroof of your vehicle, anywhere that it can stick and charge. And then, like Daniel said, you could use it in your car or your house or even out camping. You could even use it in a tent as long as you have somewhere to mount it.
So before designing this product, we had to look up on the internet and see what other people have done to make sure we haven't stolen another idea. The very first one we saw was this small thing. This is about the size of a hand, and the issue with it is it's not versatile. It's not able to go as far as what we have, and it doesn't have a USB charge port. The next one that we saw, which was only theoretical, was this one, which did have all of what we had, but kind of looked a bit weird and didn't have that like versatility and can't be placed in a certain, like, say, a windshield of a car. It would probably fall off. The last one is the Sunny, which is a Kickstarter. That's about, what, $200, $600? Some enormous cost. It's not even that useful or versatile, though. So our product is actually pretty original for this market.
It charges. The blue lights mean it's charging.
So this is how bright it is in a completely dark room. It's basically it's basically brighter than a phone flashlight, and it uses less power. Alright, so we had several prototypes before we got to our final prototype. This is the first fully fledged one we made. It's hard to see in person, but here's a picture. So it has the USB connections and the battery indicator, but at this point the lights were going to be plugged into a USB and there was no switch to control them. So in our next iteration, we added two large rocker switches that are pretty durable and are easy to turn on and off, as well as more supports for the electronics to prevent them from being damaged while the product's being moved or handled. And then our final, our next prototype has the harness as well, but it's not flexible, it's very rigid, and as you can see, this suction cup connector is already broken because of how rigid it is. And then that got us to our current prototype, which is up here, and this has the flexible harness as well as the large switches that are easy to press.
I guess we'll start here. For expert feedback, we got both engineers. Mine was mechanical. We focused mainly on the safety, like say on a windshield or on the side, so keeping everything robust and like strong enough to handle the forces in a car or say on a windshield, while also maintaining some form of safety with the actual unit itself.
So I talked to Dave Carlson. He's an electrical engineer, and he also has degrees in mechanical engineering and electrical engineering. And at one point, he worked for Underwriter Laboratories. So we focus mostly on the electrical safety and making sure that there wouldn't be a possibility to start a fire from overcurrent and preventing it from getting too hot where it would melt or hurt somebody because of how hot it did get. He also made excellent points about making sure everything stays organized inside there and that it can't be messed up or disconnected while it's being used, so that would also prevent a fire. And then we ran 2 main tests to make sure that we were operating, or the product is operating in a safe way. The first one is a thermal testing setup, and like I had said before, we wanted to make sure that none of the components, especially the lights, got too hot. So we put the LED lights inside a closed container with no ventilation and let them run for 25 minutes just to see how hot they would get, because the melting point of, or the warp point of PLA plastic, which is what the product's made of, is 160 degrees. And after 25 minutes, this light only got to 130 degrees in completely unventilated space. So it's far below the warp point and definitely within safe area.
The final test we did was just a simple battery test, but this was important because it only used one of the batteries, while in our design we can actually put in 2. With both lights on, with just 3 watts of power total, that's full brightness. The solar charge is on the ground, so you can't recharge while discharging. It lasted 3 hours and 18 minutes. So in the end, we'd probably have about 6.5 hours of full battery power with both lights on. And if you only had the first light on, it would last 3 times as long. Yeah. So that's the end of our presentation. I'm Daniel, he's Davey. This is our prototype. Thank you so much for watching.
We appreciate you taking the time to watch our video, and we await your feedback.